Okay, tonight I'd like to talk to you a little bit about the Rust programming language. They always tell me that you got to open with a joke, but to be honest, I couldn't find anything funny about Rust. I mean, it's a funny word, Rust, but who in their right mind would name a systems programming language after what happens to iron after it gets too much air in the presence of water? And certainly no one in their right mind would come up with 80s movies references to throw in as pointless humor. So, let's get started. I'm going to cover a few of these things here tonight. First of all, where can I get it? How often is it released? How is the library ecosystem? And then we're going to run our very first Rust program. And then we'll talk about what it all means. So, how do you get it? The good news is a lot of the Linux distros out there have added it as a package. So you can either yum it or apt it or APK it or whatever you want to do. But the preferred way for developers is actually to use a little tool called rustup. So go to rustup.rs. Yes, they use RS for the domains for a lot of Rust things, which may or may not interest your security people at your companies. Luckily, it's Russia. No, you're right. Now I forgot. Anyway, that's why it'll interest your security people. Anyway, so if you go to rustup.rs, you will find one of those infamous curl this and then pipe it to bash kind of commands, because that's secure. I'm a security guy, by the way. Anyway, that will automatically install the most recent stable release of the Rust compiler, and you'll be off to the races. So, because Rust is brought to us by our good friends at Mozilla, it is built on the browser-style every 6 weeks release train. So everything starts in nightly and then progresses to beta and then to stable. I have to say, they take Semver more seriously than anybody I have ever seen before. In fact, they have a tool called Comet. Whenever they're about to put out a new version of the compiler, they actually recompile everything in the package system to make sure the compiler didn't break you. So that's pretty cool. I should check my own notes here. So the good news is they do take backwards compatibility very seriously. So if you wrote something a couple years ago with Rust 1.30, it will still compile today with Rust 1.39. And we'll talk about additions. So they put in, like I said, new features with every release, but they tend to bundle them up every couple of years, and they call these additions. The most recent one is the Rust 2018 edition. All of the new features come in automatically unless they're breaking changes, in which case you have to actually tell it you want to use the new edition. That way, your code will always compile. Cargo is also part of that basic install. It is the Rust package manager. I more think of it as the Rust Swiss Army knife. It does just about everything. And it's called Cargo because packages are called crates. There we go. I didn't name these things. Don't pay me. So if you are at all familiar with Bundler from the Ruby world, you will be very comfortable with Cargo because it was also written by Yehuda Katz, believe it or not. So this is your package manager. It is your build tool. It is your test runner. It is your benchmark runner. It does a whole bunch of good stuff. And it has its own book, so you can read all about it. Also, much like Bundler, you can write your own third-party extensions for it. Anything in your path that starts with cargo dash will suddenly become a subcommand of cargo. So in this example, I install a crate called cargo bloat with a very obvious cargo install cargo bloat, and then bloat now becomes a nice subcommand. In case you're curious, bloat lets you know why your binary just got so big because you added 14 third-party libraries. All right, so like I said, packages in Rust are called crates. You go to crates.io to find them. Again, if you use Bundler, you know how this kind of works. There's a magic file called cargo.toml. You add all your dependencies. It figures out the dependencies of the dependencies, and life goes on. One interesting thing, if you are used to Bundler, especially in the old days, if two things need different versions of something deep down in the train, it actually just throws them both in. It doesn't have isolation problems like Ruby does, so you can actually have multiple versions of the same library all compiled in, and it works just fine. It also causes bloat, so there you go. In case you're wondering, TOML, if you haven't seen it before, is what I call a yact. So, with every language I've learned in the last, 10 years, they always have their own config file format, right? I learned YAML because of Ruby, etc. So they picked TOML. I don't know why. If you're having DOS INI flashbacks right now, it's because TOML looks a lot like those old files. If you have no idea what I just said, be happy. It stands, by the way, for Tom's Obvious Minimal Language. Also rolls off the tongue. All right, it's demo time. We're going to build our first Rust program. Yes. Wasn't that obvious? All right, let's hope the demo gods are with me. Okay, so cargo is also the way you make a new project. So we're going to say cargo new, my amazing first Rust program. And now I have a directory called that, so I'm going to cd in there. And now I have cargo.toml, which will look just like the one I showed you on the slide, and has no dependencies, for example. And then in the source directory, you have exactly one file called main.rs, and it has the infamous hello world. So, any guesses on how we run this? That's right, cargo run, woo! And it's done. Wasn't that exciting? So, my point in showing you this is if you're used to, when people hear systems programming language, they think of C, right? And when you think of C, you think of makefiles and missing tab stops and all kinds of other ugliness. Rust avoids all of that. So don't avoid Rust because of that. Cargo takes care of all the fun things. Also, let me go back to slides. That was a single file program, so it wasn't all that exciting. However, you can get deep and complex with your directory tree, and there are, of course, conventions for where to put things. And then Cargo will still magically find modules, link them together. You can have multiple binaries, you can have example programs, you can have tests, you can have benchmarks, and it takes care of all of that. Okay. So now we've installed Rust, and we talked a little bit about building and running a program. So let's get back to what exactly is Rust. By the way, that's Ferris, their mascot, the little crab up there. Okay, so I'm going to ask the next super obvious question, right? Everybody ready? Why do we have garbage collectors? No, seriously, why do we have garbage collectors? Everybody, I've always wondered. And it probably is kind of an odd question for me to be asking at this point, but bear with me. So, I've been racking my brain trying to come up with a better answer to the question, what is Rust, than it's a systems programming language. It's super boring. Plus, I'd have to then spend 15 minutes defining what a systems programming language is, and I'd still come up with something that wouldn't adequately do what I'm talking about. So I'm going to try something different. Because to me, Rust is a game changer. This language does a lot that we've been waiting for, or at least I've been waiting for a long time. And the reason for that lies in the answer to the question, why do we have garbage collectors? So, garbage collectors are terrible for performance, and half the time they seem to cause almost as many problems as they solve. Plus, collectively, as in computer science, we've probably put a few thousand human years into garbage collector research and tuning, and that's just for the JVM. And the answer, of course, is memory is hard. Anyone who's written more than 10 lines of C knows that that is, in fact, the answer. The second answer is compilers are hard. Back when compilers were born, computers had so little memory that they couldn't remember more than that guy. Anyway, they couldn't keep track of anything, right? They barely could spit out the code you asked them to compile back in, say, the PDP-11 days. Anybody written a compiler in class? You recognize this book? No? All right. So we didn't expect a lot from our compilers. So the result of that was compilers left memory management up to humans. And this turned out to be an extraordinarily bad idea. So, can you spot the security vulnerability? Anybody know why that's a security vulnerability? So you create a buffer that's exactly 8 bytes long, and then you call something that will read into a buffer forever. And the Stack Overflow was invented. Here's John. John coined the phrase artificial intelligence. He worked at MIT. He created the programming language Lisp. He also invented garbage collectors. And nothing against John, but with the clarity of 2020 hindsight, he really took us on a detour and put us into a place where we felt like there were only 2 options. Completely automatic memory management with garbage collectors and GC pauses and all that fun stuff, or nothing. All right. And this is why I think Rust is great, because it's something new. We've been stuck with these 2 choices for a long time, and it would be really nice to have a 3rd choice. Oh. I say nothing about how I feel about these languages. So, what sets Rust apart from everything else? And the answer, of course, is memory management. That's why I've been going on about memory for 5 minutes or more. Rust obviously does not have a garbage collector, otherwise I wouldn't be talking about all this. But to accomplish memory management without a garbage collector and without leaving it up to you to remember everything, the compiler had to get more complicated. Now we have tons of memory. Now we can do all kinds of crazy stuff. And so the compiler keeps track of absolutely everything. First of all, everything's immutable by default. And then we're going to talk about the ownership model and the borrow checker, and my favorite, the root of all evil rule. Okay. So with Rust's ownership rules, you will create a vec. They call arrays or lists, they call them vectors. So we create a vec, and we assign it to v, and then we assign v to v2. Now, in most languages, you now have 2 things that point at the same chunk of memory. In Rust, it's very different. You've now moved v to v2, and v doesn't exist anymore, which means you can't accidentally give it to somebody when it doesn't point to v anymore because you released the memory, for instance. This is what we call a use after free bug. All right. It's a simple rule, but it means that the compiler can always keep track of who owns the memory and when to release it. Where am I? Okay. Oh, that was my example. Huh. Got to read my own slides. So this print statement would not work because it's trying to reference v, and v doesn't exist anymore. But the important thing here is you get that error at compile time, not at runtime, right? There's no joy better than running a Ruby program for 24 hours straight and having it fail on the next to last print statement because you mistyped a variable name, right? This won't let you do that. Okay. The other part of the memory management system is the borrow checker. And when you first learned Rust, no, but I can try it. I borrowed the video screen. Come on. It's going to be real hard to do this without slides. The answer is always hit spacebar 1 more time. Okay. So this is what I call the shared mutable state is the root of all evil rule. You can have as many references to something as you want as long as it's read-only. If the reference you have is read-write, you can only have 1, period. Them's the rules. And the best part is the compiler is enforcing them. It's not like C++ where it pretends to enforce things and then lets you do them anyway. That's bad parenting. Okay. But what's important here is these rules seem kind of simple, but they really force you to think about your memory usage in a new and different way. But if you do it this way, you get no possibility of race conditions when you're writing multi-threaded code. You get no use after free bugs. You don't, I'll say mostly don't get memory leaks. There's always some way you can get yourself into a state where you can get a memory leak. And you're not going to have dangling pointers or other issues. The compiler just simply won't let you. So no random crashing. No, it crashes sometimes when the moon is full because some weird timing thing happened. It's really beautiful. Okay. And the last concept is called a lifetime. And this is how we decide when to release memory. Every allocation gets a lifetime. In this case, our vec is created within the function main. So its lifetime starts where it is, and it ends at that second the right-hand curly brace. And so when something goes out of scope, the compiler put code there when it was compiled to release that memory. And of course, if that vec contains other things that are also on the heap, it follows the whole train down. But again, this all happened at compile time. So you have a very good idea of when your memory is going to get allocated and deallocated, and not some random GC pause that you weren't expecting. But the beauty part is, for the most part, you don't have to worry about it. It just happens. And you end up with a program that runs faster, tends to start instantly. I love that Java lag when you try and run something. And you're going to tend to use less memory in general because you're not also loading a JVM next to your program. Okay. I'm not meaning to pick on Java, really. Okay, enough about memory. Let's talk about some other cool things about Rust. It has closures. I remember when I first started writing Ruby, I was like, I'm never going to use a language ever again that doesn't have closures. So this was a requirement for me. It also has a really cool type system. I know type systems don't excite everybody, but I'm not one of those people. It includes a neat thing called an algebraic type, which I won't go into all the details, but it means something can be one thing or another, which really helps in error handling. It has a full support for traits. If you're used to Java interfaces or something like that, traits are fairly similar, but they have their own thing. And something really cool called pattern matching, which helps you undo those algebraic types. If you've used Haskell or OCaml, these things should sound sort of familiar. But probably the most important thing about Rust I found is the community. It's really great. People are very supportive. You can jump in their Discord and just ask the stupidest question in the world, and you'll probably get some help. So I find that to be a definite bonus. But of course, there are some downsides. There have to be. With a more complex compiler come longer compile times. But they've done a lot of work in the last 2-3 years especially to lower those compile times. They've got the incremental compiler working really well now. So that first compile will still take a bit. But after that, all your other compiles will be really, really quick. I like to quote myself, by the way. All right. It also has a bit of a learning curve. Because memory management is different than you've ever seen on any language, and maybe unless you've used OCaml, it will take a bit to get used to Rust. You'll fight. It's called fighting the borrow checker. When you first get in, you're always going to be like, "What do you mean I have this reference and you can't do?" You know. But once you get used to it, it's really great. All right. So I've convinced you, right? You're going to run out and learn Rust today. Tonight. So here are some resources. They have a book. It's free. It's online. You can also buy a Dead Tree version if you want to. There's a podcast called the New Rust Station podcast. They're not doing new episodes anymore, but they have a really great back catalog. And he teaches all kinds of great things like lifetimes and borrow checkers and all kinds of weird things about the trait system that you need to learn at some point. The Rust team themselves did a bunch of really introductory screencasts at intorust.com. That's a weird inside Rust joke, but you'll get it later. If you're into the exorcism.io site that teaches you how to jump from language to language and learn lots of stuff, they have a whole directory full of Rust exercises. They have the forums, and also if you don't even want to take the jump and running that curl command and piping it to bash, you can go to their playground and actually compile and run Rust right in your browser. I should have put on the downside list, there is no REPL for a language like this, right? Because it's not a dynamic language running in an interpreter. This is the closest you're probably gonna get, and it's quick, it's fast. Plus, they actually include a lot of third-party libraries from crates.io, so even if you wanna try out a library real quick without even putting it on your machine, you can get over there. So, the next time you're thinking about programming languages, maybe you'll give Rust a try.